All right, guys, welcome back. Again, just another reminder, weather maps and scripts should be due soon. We've got projects due March 1st and a potential 3-part test. It'll be in the form, instead of a regular like 30-question test, you'll be getting those test questions in sections. So you'll take like a quiz 1, a quiz 2, and a quiz 3 on the following days. Okay, number 1, what are the 3 conditions needed for creating thunderstorms? And number 2, again, this is on page 18, briefly explain the 3 thunderstorm stages. This is our Go Blue for the day. Have these ready for notebook checks, which I believe will begin very soon. So if you guys want to add to that in the chat, take a moment. If not, I'll move on. I'm going to keep the lesson quick today because we have no in-person students to give you guys more extra time to work on your other stuff, right? Add to the chat, give you guys 10 seconds. Okay, so the 3 conditions needed what are the 3 ingredients to create thunderstorms, guys? Those 3 ingredients include moisture. Okay, you need water droplets to first make the cloud, right? Because a cloud is basically a floating structure of water gas, as you can see on the bottom left there. And then the air needs to lift it up for it to grow and extend up in the atmosphere to strengthen. Again, air lift. I believe in the video the other day, we saw that it could get up to 10 miles in height, so pretty massive. And then unstable air. So just like you have cotton candy being made from sugar, okay, that moisture needs to be stirred around and moved around within the candy, within the, what's it called again? I can't even forget. I'm forgetting. I want to say candy corn, but it's not. Cotton candy. Just like you make cotton candy, you got to stir the sugar. Just to make a thunderstorm, the moisture needs to be stirred about as well with unstable air. Number 2, the 3 stages include the cumulus stage, which are going to be from warm updraft. So the key thing with the stages, as I stated yesterday, is we need to know the how the air moves within the cloud within each stage. So like I said before, the cumulus stage is like the baby thunderstorm, right? No rain just yet, just water vapor building up. Secondly, we have the mature stage. Again, only includes just updrafts and downdrafts. So it's got both, and they're going to be equal, right? Going to be equal. This is when the storm is going to be at its strongest. So you have the strongest rainfall, strongest lightning, et cetera, right? Lastly, we have the dissipation stage. When you hear dissipation, think of like disappear or kind of fizzle out. Again, it's only going to be downdrafts that are cool, and the storm is going to be weakening over time as it begins to fizzle away and go away for good. Any questions on the Go Blue? Should been relatively short today, relatively short. Again, if I go too fast, feel free to take pictures. I'm also going to be posting this to YouTube right after I get finished recording and let you guys use the rest of the period to get some work done. Questions, comments, add it in the chat. Okay, give you guys 5-10 seconds to take a picture. Got to know those stages, the way the air moves in each one, and the ingredients. Okay, let's move on to, again, these are, like I said, on the quiz coming up next week potentially. We've got to know, identify these clouds and what stage they are in. Okay, so if I put a picture up on one of the questions that just shows a cloud with updrafts, we got to know its cumulus stage. If it's both equal, that's going to be a mature stage. And then if it's just downdrafts, dissipating, right? Okay, table of contents is the same as yesterday at 18 and 19 lightning. Again, today we're going to begin discussing lightning. We finished thunderstorms yesterday. Thunderstorms were finished yesterday. So give you some time for that. At 18, 19 lightning. Give you some time for a picture for that one. Again, if you're wondering why I'm in the auditorium, it's because my classroom is getting sprayed down for quarantine purposes. So I guess, you know, if students, you know, happen to have COVID, they go to the classrooms and they make sure they spray them down. So I was moved during the middle of the day today, so it's been an interesting day so far. Anyways, moving on, guys. Do not write these questions down, okay? Just some questions to think about. What causes lightning? What causes lightning? Add in the chat or speak out loud if you like. Anyone know what causes lightning? What cause? Don't write these down. We're just watching. Again, what causes lightning? Anybody know? Anybody know? Give you 10 seconds to answer in the chat. What causes lightning? Another question is, why is lightning so frequent in Florida? So, I mean, we're pretty much the lightning capital of the United States, if you guys didn't know. And then, what are safety precautions that we need to take with lightning strikes? Like, so if we're like around lightning, what do we need to do? Like, what needs to go? What needs to happen, right? Okay, so some things to think about. Lightning. Okay, what causes it? Well, it's going to be charges, specifically charges in the clouds and charges in the ground, right? So we've got charged particles building up in the ground and the clouds. Okay, that's going to be what causes our lightning. And our next question is, why is lightning so frequent in Florida, right? So you're going to have opposite charges in the ground and in the cloud. It's going to build up and cause that bolt, create those bolts. We'll explain more of that later. Why? And again, guys, do not take a picture of this. Do not write this down. This is just for discussion sake. You'll see what to write down in yellow here in a little bit. Why is lightning so frequent in Florida? Why is lightning so frequent in Florida? Well, again, what builds up storms? Moisture. What is Florida surrounded by? Water. And it's very hot, so a lot of it's evaporating. So the combination of moisture and heat are going to make Florida a place with a lot of lightning and thunderstorms. And safety precautions to take, guys. Again, some things that I was surprised to hear a lot of my students did not know is that when there's lightning, and this is really important for us here because we live in one of the top lightning places in the United States. When there's lightning, you do not want to stand tall. You do not want to stand near a tree. Don't hide under a tree. That's a very bad idea. You want to stay away from tall objects, whether it be light poles, telephone poles, things like that. You want to be in a flat, low-lying area, probably crouching down with your heels together. I'll explain why you want your heels together probably on Monday. That'll be for like what happens to your body when you're struck by lightning, how to protect it. One second, guys. And sorry about that. 1 second. And then let's see. Oh, and your car is actually completely safe. And you can look this up. Take my word for it. If you're outside and there's no buildings, just get in your car because all the metal outside your car, the lightning will surge around it. And it will not touch you on the inside. So the lightning strikes, it will not go in your car, it only goes on the outside. Now, that is not the case for convertibles. If you have a convertible with like the leather hood or the leather top or that opens up, that's a dangerous situation. You don't want to be in one of those. Planes are also commercial jets. We see it at airports. Those are also very safe in lightning as well. So lightning, if you're inside in a vehicle, in a plane, you're totally safe. Totally safe. Okay, and that's get inside, car is safe, positioning, right? Common sense stuff. Okay, go ahead and go to page 19. I want you guys to take a picture, and if you want to write this down. I'll give you a minute or two. I'll walk around when you guys do this. Title, page 19, Lightning Science. Lightning Science, okay? And go ahead and write that down. I'm just going to give you guys a minute or two, take a picture, write it down, and we'll discuss it and get it going here. Okay, so go ahead, start that, guys, start that. If you can write fast, start writing it down. If not, I mean, I recommend always just take a picture and kind of listen while you write down maybe as we go along. So that way it prevents you from having to watch all the YouTube video. So give you guys a moment. I'm gonna get a drink of water here and I'll start talking more about it as you guys finish up page 19. Again, this is the most we're gonna write today. We'll see one more thing. I think a little diagram we'll draw in a little bit. 1 second. We'll get talking about it here a little bit. Okay, so let's begin discussion as a lot of you are finishing writing this. Okay, so lightning, just so you guys know, is the, again, transfer of energy through charged particles, both in the ground and in the cloud. All right, and we're going to see some of this being caused due to air rushing a lot in the cloud, some of that static energy. Okay, now just so you guys know, lightning is a plasma. Okay, so it's not a solid, liquid, or a gas. Think of a plasma like a supercharged gas, right? Supercharged gas, okay? Keep in mind for the charges, the top of the cloud is positive, the bottom of the cloud is negative, and the ground is positive. So opposite charges attract, and that's gonna be what causes that surge, that bolt to form. So go ahead, if you're not finished, make sure to have a picture. We're gonna actually go ahead, and I think before I don't want you to draw this, ignore that. I'm going to show you something better that I drew up in my classroom today. I think you guys can see it. Hopefully, you know, it shows up on the screen okay. But yeah, so just understand that dynamic, that breakdown of the way the clouds are and how lightning forms, right? So let's skip this. Let's do a card question before I have you guys write the diagram to finish up for the day. Our first card question for today, again, really important. You guys are going to see this on your multi-part test, the multiple section test next week. We've got temperature, wind speed, and dew point of this weather symbol. So we got to know our weather symbols, right? Tell me the temperature, wind speed, and dew point. Is it A, 67.15 knots, 46, B, 72.25 knots, 67, C, 67.15, 72, or D, 72.15, 67? Got to know our weather symbols. Please participate in the chat so I can know you're with me here for the participation. Give me your best answer. Again, A, B, C, or D. You got to tell me the temperature. If you guys are stuck, look at page 9 where you wrote your weather symbol answer key. We also have the Go Blues that we've recently done that can also help you out with this. I'll give you a moment. Wait for the chat to get started. So again, temperature, wind speed, and dew point. Okay, again, looks like I need Tatiana. Thank you, Tatiana. I still need Lakia. Good. Thank you, Michaela. Thank you. Melissa. Thank you, Joseph. Thank you. I'll give shout outs to who's right in a second. Sanaya, Yorkies, Amira. Looks like Diego, Daniela. Thank you, Yorkies. Again, make sure to answer the question, guys. This could be a question you see on your quiz. Practice makes perfect. Oh, thank you, Daniela. Diego, thank you. Guys, got 10 more seconds to give me to provide answers. All right, Lakia, thank you. I want to give a shout out to, shout outs to, Lakia, Daniela, and Michaela getting the right answer. The answer is going to be, guys, D, 72. Again, temperature is always the top left number. Then we have 15 knots. Again, at the end of our line here, we've got 2 feathers, 1 full feather, 1 half feather. That's 10 plus 5, that's 15. And then we've got 67. which is always the dew point. The bottom left number is always the dew point. Also keep in mind the top right number is going to be pressure. Top right number is going to be pressure. Solid job, guys. Let's go ahead and move on. We're going to ignore that. I'm going to go ahead and let me get full screen here because I've got to show you what I did instead for this. Okay, so what I want you guys to write down on the, on the bottom of page 9, the rest of it, I've got this right here, okay? This is the anatomy of a lightning bolt, anatomy of a lightning bolt. So go ahead, take a picture if you can. I'll zoom into the top. Here's a full picture look at it, okay? And then what you guys can do is I'm gonna just show the top half and the bottom half so it's easier to maybe read, okay? But again, on my computer, it's showing it backwards. So hopefully on your cameras or on your computers, it's showing it normal, face forwards, right? Okay, so as you can see here, we've got the cloud. I want you to draw the cloud and draw the positive charges on the top of the cloud and draw a bunch of negative charges on the bottom of the cloud, okay? Then you're gonna make the ground and draw a bunch of positive charges. Why? Because we need opposite charges to form a lightning bolt from the bottom of the cloud to the ground, okay? So draw that and then draw two lightning bolts. Do not have them connecting, okay? Anybody else need a picture of that? Again, lightning diagram. It doesn't need to take up a full page. It just needs to be like half the page, if that. Okay. All right. And if we zoom in, all right. If I look closer, okay. What I want you to do is once you've made your two lightning bolts, you need to label the top one step leader. That's going to be a negative charge bolt. And the bottom one will be called the return stroke. Okay, bottom one return stroke. Okay, again, that's going to be the return, and that's positively charged. Okay, now here's some interesting stuff. Oh, you know what? I just realized I totally forgot to show you the lightning video examples. I'll show that in a little bit. Okay, so lightning strikes in the middle of the atmosphere. It does not strike the ground. Okay, it does not strike the ground. Right. So when you see lightning, you typically think it's like one bolt. Again, anyone else need a picture of this? I'm just keep it up for a second. If you need a picture, please let me know in the chat. Otherwise, I've had it up for some time. Okay. So if you guys didn't know, we all good? Anyone else need a picture of that in the chat? I'll give you 10 seconds to say something in the chat. Otherwise, I'm just going to assume you're good. Okay. So let's go back to where we were. Okay. So and again, do not write this down. Don't write this down. Oh, someone in the chat maybe needs a picture. Where's my chat at? Where's my chat? Is my chat? Where's my chat at? Hold on. Looking for my chat. Where is that? Okay, Joseph. Okay, 1 second, Joseph. All right, Joseph, here is the full diagram. I'll leave this up for 10 seconds. Okay, I'm going to show the text a little closer. Here is the bottom part of the diagram. I'll leave that up for 10 seconds. Easy to read. Two lightning bolts. All right, great. Okay, so let's go back one second, guys. Okay, so yeah, don't write this stuff down. It's just, I made better notes from it, but like I said, the step leader is the top bolt. The return stroke is the bottom bolt. Now, yeah, so a lot of us growing up believe that lightning just comes from the sky, just strikes the ground. That is false. When you are struck by lightning, you are actually struck by your feet first before your head. There's a bolt coming out of the ground, right? So that's why if you ever could get struck by lightning, you got to put your heels together because that bolt could go through your feet only instead of through your legs and through your torso. So it could save and save your health. Big time. Very important there. Okay, so make sure again we draw those charges with the clouds on the ground. We have those bolts. We label those bolts, and then we have the explanation again. Lightning, when it strikes, it's going to be hitting two bolts, crashing in the middle of the atmosphere. Okay, and when they crash, it creates an explosion. It's like an air explosion, right? And that air explosion actually gets hotter than the surface of the sun. That's how powerful it is. And that's where you hear thunder. Keep in mind, is the speed of sound faster or the speed of light? The speed of light is faster. That's why you see a flash, and then it's like, then you hear the rumbling thunder, right? What was I going to say? Yeah. Again, usually you've always thought one bolt probably because the speed of light is so fast. You don't see the two bolts at first. It just happens so fast. It looks like one bolt. Hey, what's up, Jaranisha? Oh, from yesterday. No problem. My room's getting sprayed down. So just put it right there. You all say, yeah, given what was going on yesterday, I know I couldn't. Sorry, guys, 1 second. Yeah, given what was going on yesterday, you're all good. No worries. It was just crazy afternoon. So I'll see you in a little bit. We'll have an interesting class period. You'll have extra time to get work done. I'll see you. All right. Sorry about that, guys. Let's go. Let me show you some of those lightning examples in the video. Let me get the video set up first. Okay, 1 second. All right, so let's go check it out. It is on mute currently. Okay, so you have this guy, he's getting out of his car, right? And just seconds away from potential danger. And we see, look at the tree in the back, bam, right? You guys see that? We've got just the tree just kind of imploding. Power of lightning, right? Just a key thing here, guys. Never ever hide under a tree when there's lightning. Bad idea. Never ever. Okay. And I would. Okay, you see that surge there? Again, we see that surge. Cloudy day. Dangerous, right? Here we have one. Again, it can happen in the daytime as well. Lightning can happen in the daytime. Okay. And then, okay, here again, another great reason. Oh, my bad. It's all being all slow. Another great reason why you should never, ever stand under a tree, right? Sorry for the volume there. Here we have one that hits like a power line or hits like a generator. You see that reaction there, right? In the building. And water, also very dangerous. See again. Sorry about the volume, guys. Bear with me on this. Also, it's safe to drive in your car. Look at the van on the left. Let's see what happens to that car after it gets struck. Good. Car is fine. Being in a car is safe. Cars are safe. Planes are safe for lightning. Rainy day, rainy day. Okay, and here's another one, right? Just sitting in this front yard, and then bam. Okay, so just a bunch of good examples there, All right, let's go back and go to where we left off to finish up. I think we're kind of done with notes for the day, guys. Last thing I want you to look at is our lightning types video. So go ahead and jot this down on page 18 below the Go Blue. What are the different types of lightning? It'll be the last video of the day, and then we'll do a card and we'll play a little review game. Play some Kahoot. Again, do not sign out. We will take attendance at the end again here. So what are the different types of lightning? Page 18, I'm going to give you guys a second for that. All right. Again, get a picture. If you need more time, again, just put different types of lightning. What are the different types? Let's go ahead and let me get the other stuff set up here. 1 second. Oh, you almost saw the. No. Don't. You didn't see the answer there. Okay, 1 second. Got to get the other videos loaded. And last video of the day, guys. Last video of the day. And we've got a little commercial I'm going to let play for our video that I want to begin. All right, let's go ahead and let me get this started. Okay, so again, just list off the different types of lightning. List off the different types of lightning.
We can't see the video.
Oh, I got you. 1 second. Thanks for letting me know. Can you see it now?
Yeah.
Okay, great. Here, let's check it out.
Whether it's up in the sky during a thunderstorm or helping send a DeLorean back to the future, lightning is a beautiful, dangerous phenomenon. Most people picture lightning as a brilliant white strike that flashes between a cloud and the ground, but there's also lightning within clouds and between clouds. Plus, there's colored lightning and even glowing ball lightning. It's all about a buildup of electric charge and the release of that energy in a bright flash. To have a lightning strike, you first need to separate positive and negative charges within a cloud. Clouds are essentially a bunch of really small, dust-borne ice crystals and water molecules. During a storm, the air is moving around and making these particles collide. So one theory is that some negatively charged electrons from the upward moving water molecules get transferred to the downward moving heavier particles. This makes the bottom of the storm cloud more negatively charged and the top of the storm cloud more positively charged. And remember, like charges repel each other. So the electrons near the Earth's surface are repelled away, and the ground underneath the cloud is left with an overall positive charge. All this charge separation creates a strong electric field between the ground and the cloud. Basically, an electric field describes how much force and in what direction a positive charge would go if it were in the field, in this case, upward toward the cloud. And when the difference in charges builds up enough, the first stage of lightning begins. Most of the time, we see negative lightning. This is when the electric field grows strong enough that...
Right? Negative lightning. Our first one is negative lightning. We already saw earlier the charge buildup, right? The bottom of the cloud's negative. The ground is positive. The opposites attract, right?
Stage of lightning begins. Most of the time, we see negative lightning. This is when the electric field grows strong enough that an invisible channel of negative charges, called a stepped leader, begins to branch toward the ground at about 50 meters per microsecond. Meanwhile, an upward moving channel of positive charges, called a streamer, rises up. They meet with a huge bright flash that travels up. Not to mention the heat, over 25,000 degrees Celsius, which is about 5 times hotter than the surface of the sun. Because the negatively charged electrons stream from the cloud down to the ground, it's called negative lightning. There's also the much less common positive lightning, with a net transfer of positive charge from the cloud to the ground instead. These strikes start at the top of a cloud where positive charges hang out, so they need to travel through much more air to reach the ground. So they need even more charge separation, which means the strikes can be up to 10 times stronger than negative lightning. In fact, these strikes can even break apart molecules in the atmosphere into ions, which can collide with other molecules like hydrogen and oxygen and cause photons of red light to be released. If this happens, we call them red sprites. They usually only last milliseconds and can kind of look like giant jellyfish in the sky. And if that sounds cool, there's another type of lightning called a blue jet. This lightning occurs when large amounts of positive charge stream upward in order to neutralize the charge in the cloud. The blue jets can get up to 40 kilometers high, but only last for fractions of a second. And scientists believe their blue color comes from ionized nitrogen molecules. Even weirder is ball lightning, a glowing grapefruit-sized ball of gas that lasts up to 20 seconds. But scientists aren't quite sure what causes it. One theory suggests that ball lightning is caused by ions made by a lightning strike near glass, like a window. The ions could pile up on one side of the glass and create an electric field, exciting air molecules on the other side, which would release photons and create a glow. Another theory suggests that elements in soil are to blame. In 2012, scientists in China recorded the first video of ball lightning. They monitored the light it emitted and found that it contained silicon, iron, and calcium, which...
All right, so again, some of the lightning is going to change colors based on the elements that are in the ground. So pretty interesting, cool stuff there. And just so you guys can see, saving you guys some time here. Oh, 1 second. Let me go ahead and go back to where we were at. So we had the, just so you guys can see, again, we had positive and negative lightning. Those are the more common ones we see, but also some of the cooler, more rare ones are red sprites. blue jets, and ball lightning. Again, positive